बाकी लोग कहाँ हैं भाई? देवाशीष?
यस सर।
बाकी लोग नहीं है क्लास में?
सर पता नहीं है क्यों नहीं है।
मीनिंग कोई और क्लास या लैब या कुछ और तो नहीं था आज इस टाइमिंग पे?
नहीं सर आज नहीं था।
तुम लोगों ने में कितने लोग यहाँ पे ऑफलाइन आके लैब कर चुके हैं? उन्होंने 3 सॉफ्टवेयर वाली लैब की थी आई गेस। यूसुफ?
यस मैंने भी दी हर्ष।
हर्ष? किस सॉफ्टवेयर पे की थी बेटा
यस
तुम
सर।
लोगों ने?
सर पी स्पाइस 9.1 था शायद।
स्पाइस 9.1 पे किया था। ठीक है। अभी जो हम लोग उसी एक्सपेरिमेंट को, ठीक है, तुमने जो किया था वो सिंटेक्स बेस आई गेस किया होगा। ठीक है। एक और तरीका उसका हो सकता है कि हम उसको उसका सिमुलेशन भी कर सकते हैं। मीनिंग तुम वहां पे जो तुम लोगों ने किया था उसमें तुम लोगों ने प्रोग्राम लिखा होगा, राइट? एक और तरीका ये भी हो सकता है कि हाँ हम उसको उस पूरे सर्किट का जो हमारा एम्पलीफायर सर्किट है, मॉसफेट का कॉमन सोर्स एम्पलीफायर सर्किट जो है वो पूरा सर्किट हम सिमुलेट करें। मीनिंग 1 बाय 1 ट्रांजिस्टर, मॉसफेट, रेजिस्टेंस और सारी चीजों का मिला के उसका सिमुलेशन करें, पूरा सर्किट डिजाइन करें एंड देन उस सर्किट का फ्रीक्वेंसी रिस्पांस देखें। ठीक है। एक तरीका ये भी हो सकता है कि तुम सिंटेक्स लिख के, मतलब प्रोग्राम लिख के देन उसको सिमुलेट करो। दूसरा तरीका ये भी हो सकता है कि उसको डायरेक्टली सिमुलेट करो। ठीक है। तो अभी एक वीडियो की हेल्प से हम लोग डायरेक्ट कैसे सिमुलेट करेंगे वो चीजें थोड़ा सा देखेंगे। वीडियो की वॉइस एंड उसका विजिबिलिटी प्रॉपर है सभी को?
So N-channel enhancement type MOSFET from the transistor family, enhancement type N MOSFET. I will choose 2N7000 transistor, click OK. I will pick and place the transistor here. Along with transistor, to bias the transistor we require the basic components, that is resistors. So from the basic source family I will pick resistor. We can choose any resistor. Later on we can change the value of resistor of required value. So I will pick the resistor. We can take multiple copies of the resistor. We can change the value. So I will copy the resistor. Control C also works, and control paste the value. Number of times you paste, that much number of components of the resistors will be observed. Now I want to rotate the resistor, so I will select all of them at a time. Control plus selection, and I will make control R, or if you right click it goes to 90-degree shifting also. So I will place the values of resistor. So if I connect it here, which will be acting as a RD resistor, this I will using as a RS resistor connected in source in series with the source terminal. this is the resistor R1 for providing the proper voltage divider bias. Resistor R2. Now we'll connect this resistor one by one. So turn is required, then do the connections and join it here. Join this resistor with this point. Join drain terminal with the resistor. I will join these two resistors also. Join it here. Fine. Now along with this, one voltage source also will be required. So from the sources family, place sources power source. I will choose initially VDD power supply that is required to bias the resistors. Then one ground connection is also required. I will pick one ground connection. Along with that, AC signal source will also be required. Signal voltage source. Power source, I can choose AC power source from the family of sources. Power sources, choose the AC power and make it OK. So because that is required. This is the AC signal source that is required for to be amplified. So I will join these 2 points here. So these are the components. Join the ground connection to this point. Now along with the resistor, resistors plays the role of stabilizing the state operating point. Along with the resistors, capacitors are also required. So I will choose the capacitors. So basic capacitor, make it OK. Choose the capacitor. 3 capacitors are required. 2 is a coupling capacitor and 1 is a bypass capacitor. So I will make copy of this. Initially I can make the copy and then we can change the values. So one more is required as a bypass capacitor. So this will be acting as one of them will be acting as a bypass capacitor. So I will bring this C1 over here, which will be behaving as a coupling capacitor 1, coupling capacitor 2. So if I call this as a coupling capacitor 2, that is reconnected to the output terminal. This is capacitor. Now I will rotate this by Control R, or you can right click and do the connections and rotate it vertically. Join capacitor. This is acting as a output coupling capacitor. This will be acting as a input coupling capacitor. Now I will do the connections first and then we'll change the values of components and sources with required values. So these are the components and sources which are required for designing of a single stage common source amplifier. As this source terminal is grounded, so we call in this as a common source. Single transistor is there, so it is a single stage transistor amplifier. Now I will change this to the required value. VDD supply here, even if the positive, this symbol indicates that positive is connected to this point and negative even if it is not shown, but it is connected to the ground, negative terminal, even if it's not shown directly, but it is connected to the ground connections. Okay, so now I will change the value of this. Let the name be as it is. Its value I will make this as a 15 volts. I will change the values of this input coupling capacitor to tens of microfarad. Same for this capacitor. I will make its value equal to 10 of microfarad. Small u makes micro. And value of this bypass capacitor, I will call it's of the 100 microfarad value. I will change the name of this capacitor so it becomes convenient for us to understand. So this is a bypass capacitor CB. So I will call this as a input coupling capacitor. So label, we can call this as a CIN, input coupling capacitor, and this as a output coupling capacitor. So I will call label. When you double click on the components, multiple tabs are there. So I will call this as a C out. Okay. So now I have to change the values of resistor. R1, I will choose the value of R1 as a 20 mega ohms. Value of R2 as a 10 mega ohms. Value of this resistor is a 2K. and value of this resistor is a 1k. Okay, already it is 1k and did not change. I will change the label of this resistor. I will call this resistor as a RS as it is connected to the source terminal. So let us call this as a source. It becomes easy for identification. And this is, I will call this as a RD. Go to the label tab and give the label as a RS.